Good morning, students. So we will start laws of chemical combinations. Students, we know elements combines together and forms compounds, and it is governed by certain laws. And these laws are known as laws of chemical combinations. We have law of conservation of mass, law of gaseous volume, Avogadro's law of constant composition, law of multiple proportions, and law of reciprocal proportions. So, in this video, we will study one by one law with the examples. Okay, so our first law is law of conservation of mass. According to this law, in chemical or physical change, the mass of the reactant is equal to the mass of the product in that reaction. Means the total mass of the reaction is constant. So mass neither be created nor be destroyed. And this law was given by Antoine Lavoisier. Example, suppose we will see the example of physical change. Suppose in a conical flask, if we take 250 gram of ice cubes and this conical flask is heated. After heating, we will observe that ice cubes melts into water and the amount of water or mass of the water is 250 gram. Means mass before melting and after melting is 250 gram. Means mass of reactant and product is same. So mass is conserved. Similarly, if we see the examples of chemical change. In chemical change, suppose X plus Y gives A plus B. X plus Y reactants, A plus B are the products. So the mass of the reactant should be equal to the mass of the product. Okay, for example, if in a conical flask we will take copper sulfate and in this copper sulfate solution we will add NaOH solution. So this is the example of precipitation reaction. But after some time what happened? We will get the precipitates and we will get the blue precipitate of copper hydroxide, and in test tube we will get a colorless solution. So the mass of copper sulfate and NaOH is suppose 60 gram. So according to our law, the mass of copper hydroxide and Na2SO4 should be 60 gram. Okay. So this is the example of chemical change of conservation of mass. But if we take the example of uranium, which is converted into thorium, the mass of uranium is 235 and the mass of thorium is 231. Here the mass of the reactant is not equal to the mass of the product. Clear? See, the mass lost is 235 minus 231, means the total 4 unit mass is lost. So what about this lost mass? See, this lost mass is converted into energy. So we have a new concept that mass can be converted into energy according to the E equal to mc square equation. Here m is the mass which is lost, c is the speed of light which is equal to the 3 into 10 to the power 8 meter per second. Okay. It means the law of conservation of mass can be converted into law of conservation of mass and energy. Now it is called law of conservation of mass and energy, where mass and energy are interconvertible. Okay, and the total sum of mass and energy will be constant. So the mass and energy are interconvertible, but the total sum of mass and energy during any chemical or physical change remains constant. Okay, now uranium 235 is converted into uranium 231. So the total mass 4 unit which is lost. Okay, so here the mass and energy will be equal to the constant. The next law is Gay-Lussac's law of gaseous volume, which is specially for the gaseous reactants and products. Here, if we take X volume of gas 1 and Y volume of gas 2, these two gases are mixed together and it forms a new gas 3 with the volume Z. So here the ratio X, Y and Z should be a whole number ratio. Okay. So according to this law, when gas reacts together, they always do so in volumes which bear a simple ratio to one another and to the volume of the products if these are also gases at a constant temperature and pressure. Okay, so under similar conditions of temperature and pressure, the ratio of the volumes will be a simple whole number ratio. For example, if 1 volume of nitrogen is mixed with 3 volume of hydrogen, so we will get 2 volume of NH3. So here the ratio of volumes of gases is 1:3:2. Okay, this law is only for the gaseous volumes. Okay, now if we see the another law, which is a Avogadro's law. According to Avogadro's law, equal volumes of gases at same temperature and pressure contains equal number of molecules irrespective of nature of gas. Means suppose 1 volume of hydrogen contains n molecules and 1 volume of chlorine contains n molecules. Means see, if we take 1 volume of hydrogen, okay, and if we take 1 volume of chlorine, so here the volume of both the gases is same. Okay, so number of molecules will be same at constant temperature and pressure. It will not depend upon the nature of the gas. Means volume is directly proportional to the number of moles. Okay, here see, if hydrogen contains 1 volume, so n molecules are present, and if it is hydrogen chloride, that is HCl, and if its volume is 2 mole, so its molecules will be 2n. So simply V is directly proportional to n, where n is the number of molecules. Okay, another example we can see. See, 1 volume of hydrogen reacts with 1 volume of chlorine and it gives 2 volume of HCl. Means H2 plus Cl2 gives 2 HCl. So here we will get n molecules of hydrogen, n molecules of chlorine and 2n molecules of HCl, because volume is just doubled. Okay. Now law of constant composition. According to this, a chemical compound is always found to be made up of the same elements combined together in the same fixed proportions by mass. Means, suppose we will take the example of CO2. See, C plus O2 gives CO2. So 12 gram of carbon combines with the 32 gram of oxygen and it forms CO2, where 12 raised to 32 ratio is present. See, 12 carbon and 32 is oxygen. Okay. Now this is the 3 raised to 8 ratio. Means CO2, which is obtained from the combustion of coal or by the decomposition of calcium carbonate, the ratio of carbon and oxygen will be same. Means here the elements composition remains constant. CO2 कहीं से भी मिल रहा हो, बट द कार्बन और ऑक्सीजन का रेशियो सेम रहेगा. नेक्स्ट इज लॉ ऑफ मल्टीपल proportions. See, when two elements combine to form two or more chemical compounds, the mass of the one of the element which combines with fixed mass of the other, it bear a simple ratio to one another. For example, suppose, see, sulfur forms two oxides, SO2 and SO3. Okay, in SO2 we have sulfur 32 gram. In SO3 also we have sulfur 32 gram. Means the mass of sulfur is 32 gram. But in SO2 oxygen is 32 gram, and in SO3 we have 48 gram of oxygen. So here the ratio of oxygen is 32 raised to 48. That is 2 raised to 3. So this follows the law of multiple proportions. Clear? Here the ratio of oxygen in SO2 and SO3 is 2 raised to 3. Okay. So next is law of reciprocal proportions. This law we will explain with the help of an example. Suppose we will take three elements A, B and C, and out of these three elements we will fix the mass of any one element. Suppose we fix the mass of C. Okay, now see, the C and A will form the compounds of A and C. C and B form the compounds of C and B, and AB will form the compounds of A and B. Here the ratio of A and B in compound of A and C and compound of CB, and the ratio of A and B in the compound of AB. It will bear a simple whole number ratio, or it will have same value. Okay, clear? But we have to fix the mass of any one element. So according to this law, the ratio of the masses of two elements A and B which combine separately with a fixed mass of the third element C is either the same or some simple multiple of the ratio of the masses in which A and B combine directly with each other. For example, suppose we have three elements, hydrogen, carbon and oxygen. Hydrogen and carbon will combine and form CH4. Hydrogen and oxygen will form H2O. Carbon and oxygen will form CO2. In CH4, hydrogen 4 parts and carbon 12 parts present. In water, hydrogen 2 parts and oxygen 32 parts present. Okay, and in CO2, carbon and oxygen, here carbon is 12 part and oxygen is 32 part present. So in CH4 and H2O, the ratio of carbon and oxygen is 3 raised to 8, and in CO2 the ratio of carbon and oxygen is 3 raised to 8. So it explains law of reciprocal proportion.